Can you see the slide?
Yes,
Yes,
sir.
sir.
Okay. So what you have, what we did so far actually, uh, so far we did this our mass balance, momentum balance, and rectilinear coordinate and the cylindrical coordinate. And there we have studied streamline and laminar flow, stream and turbulent flow. We have not talked about it yet. We will talk it later actually. And then we have come up that continuity equation for both the cases, cylindrical coordinate also and rectilinear coordinate also. And there we have also identified that how do we identify the dimensions of the flow, whether it is one-dimensional or two-dimensional flow. In that case, you are just finding your derivative of, let's say, your velocity vector with respect to your x coordinate, y coordinate, z coordinate, or sometimes even a time derivative also. So based on that, you can actually tell whether it is steady or unsteady. Steady means your time derivative must be 0. And if you are talking about two-dimensional, so you would have only two derivative, which should be non-zero. Rest of the derivative must be 0. So this derivative could be either in x direction or in y directions. Correct? So most of the time we are talking about, let's say, 2D flow. Let's say you are talking about the river. So river may you have a width or you have a length. So the no flow goes in z direction actually. So most of the time you have a 2D plane. On that your flow is flowing. So for that, for ease of the calculation, the something is being derived is stream function. Because generally you have two velocity component, one is u, one is v. Now u and v are clubbed together in the name of the stream function, and which is given by means the nomenclature psi here. So let's say if you are talking about 2D incompressible flow, for that your continuity equation is given by this del u upon del x and del b upon del y equal to 0. So if you want to write continuity for 3D or steady or unsteady flow, so you will have two more terms here. One is del rho upon del t plus rho plus del rho u upon del x plus del rho v upon del y plus del rho w upon del z. This is your continuity for 3D flow. Now you are already putting a constraint here that incompressible, so density is constant. And if density is constant, so del rho upon del t term will get cancelled here. So no matter whether it is steady or unsteady, so both the case means the stream function is valid actually, because you are not making any constraint on time here. You are making a constraint here only incompressible flow. That too in 2D only. So you will get only this term del u upon del x, del b upon del y in xy plane. If you want to write yz plane, you will get del v upon del y plus del w upon del z. If you want a zx plane, then del u upon del x and del w upon del z actually, right? So this any two coordinate, you just add them up, you will get that is your continuity actually. Now, stream function is defined in this way. This is the way it is being defined only. That velocity, x direction velocity is given by del psi upon del y, and y direction velocity is given by minus of del psi upon del x. This is the standard, the nomenclature, which is being followed actually. Okay. Now, we have to put this back because it should satisfy your continuity. The means the equation only, because main thing is your continuity. To satisfy the continuity, these psi are taken in such a way that if you will substitute this here, it should satisfy it actually. So if you will substitute u here, so what will you get here? You will get what will you get if you will substitute u from here del psi upon del y into in this term? What will you get? Uh, Let me write it here. Sorry. So we were here actually. So in this case, uh, so your continuity was here. This one here. This is where your continuity part. So it will not change here. So if you want to write here, let's say your continuity. So what your continuity is, can you have here del u upon del x plus what you have del v upon del y, right? This is what your continuity equal to 0. Now you have taken psi in that way, where psi you have considered that u is del u upon del y. So del psi upon del y. So if you substitute that term here, so just on left hand side, LHS only. So in LHS, you are substituting the expression for u. So what expression for u you have taken for psi in terms of psi? Can anyone tell?
Del psi upon del y.
Right. So it was your del psi upon this del y, and at this place you have taken this is not capital. So at this place again you have taken in terms of minus sign here, and here you have taken x. So if you will differentiate that, what will you get the next line? So you will get here your del square. Here you will get x del x del y, and same thing you will get to the this side with the minus sign. Okay, so your finally this is coming your equal to 0. So that psi is your u is taken in such a way in terms of psi that is to satisfy the continuity only. So your left hand side is coming equal to the right hand side. So whatever you have considered for u is satisfying the continuity. Therefore, your stream function definition, whatever you have chosen, is correct. Now next part here. So this is for the stream function for the rectilinear coordinate. Let's say same way we have for cylindrical coordinate. So cylindrical coordinate, your continuity is given by this term, that r del r rho br upon del r plus del v theta upon del theta. This is continuity, your r theta plane. Now in r theta plane, your the extreme function is defined by this. Actually from here, velocity in r direction is given 1 upon r del psi upon del theta, and theta direction the velocity is given that minus del psi upon del v. So same way, can you prove this also, that the left hand side equal to the right hand side? Can you people do that for this case? All of you should try it as I did for previous one. Same way you did for the cylindrical coordinate, just satisfy that your left hand side equal to the right hand side in terms of putting your Vr 1 upon r del psi upon del theta and V theta equal to minus del psi upon del r. Just substitute this into this and let's see what is coming. Just do it. It won't take more than 2-3 minutes actually.
Done, sir.
So is it coming?
Yes, sir.
Okay,
0, sir.
fine. Okay, fine.
Yes,
So
sir.
now we want to write the stream function along a streamline. So you have been taught the streamline, and we want to say that how does it vary along the streamline. So this is your equation given for the streamline. The streamline equation is given to you del by dy upon dx along the streamline is always given by v by u, right? Is this fine? This is what the streamline is
Yes,
given,
sir.
right?
Yes,
Now from here you can readjust this, so you will get u dy minus b dx equal to 0. Now you substitute your expression for u in terms of psi and expression for v in terms of psi. So your u was del psi upon del y into dy here you have. Then your v was minus of del psi upon del x multiplied by dx. So if you say from this also it is coming equal to 0. It means the derivative of psi along the streamline is also 0. It means it is constant. Okay, so if you are having on a streamline, your the stream function of that streamline will not change. It is constant. Okay.
Hello.
Yeah.
So previous slide, sir.
Previous slide. Okay. So it was this.
अच्छा, वेट सर हम कर रहे थे जब तक आपने सर स्लाइड चेंज कर दी.
थोड़ा फास्ट करिए. हो गया. Now it is done.
So just 1 second, Dr. sir.
कोई no problem. Take your own time, do it.
Okay, sir. Done.
So you got your LHS equal to the RHS, right? In terms of the stream function also. So you can say that the stream function satisfies your continuity. Fine.
Yes, sir.
Now we are just going ahead from there, that what would be the stream function value along a particular streamline. So from this slide or the derivation, we have proved that along the streamline, the derivative of the stream function doesn't change. It means it is constant. Okay, so it can be 1, 2, 3. Let's say you have one streamline, the another streamline, the stream. So you, in a particular fluid, you will have infinite number of the streamlines. So each one would have its own stream function. It could be a 0 value, it could be a 1, it could be a 2, it could be 3, it could have any value, but it's constant. It is not a function of x, y, z. Okay, therefore its derivative is coming equal to 0. Fine. So let's see how can we use it in our purpose for in case of fluid flow actually. Now, let's see, you have a flow. And now in that case, you have considered 3 streamlines. So one streamline is this, for that the stream function is psi 1. Another streamline 2, for that the stream function value is psi 2. Another one you have, let's say psi 3. So for time being, we are considering 3 streamlines. So let's see what can we calculate from here, or what will we calculate from here. Can we calculate the flow rate something, because the stream function your satisfy your continuity part. So continuity is practically a mass conservation. So by chance your density is constant, it means you are already talking about the density constant, incompressible flow for the stream function. It means your volumetric flow, right? So you can calculate the volumetric flow from here. So let's say you have taken one cross section here. So if you want to draw a perpendicular the line here between the streamline 1 and 2, so you can draw one thing from the here, right? At point A and point B. So point A coordinate, let's say x1, y1. Point B coordinate, because the x is not getting changed, so that would be your x1, and your y has changed as y2. Okay, so you would reach to the streamline 2. Now, if you want to move it, let's say horizontally, so in that case, you are changing only x, y is not getting changed. So for coordinate of point C is just x2 because you have changed from x1 to x2. Your y2 remains constant. Fine?
Yes,
Is that
sir.
fine? Now, let's say we want to actually calculate that how much flow is going in this side, in x side, because this is now the cross section. The point AB is one of the section, and we want to calculate that how much flow is crossing this particular section actually. So for that, if we know that how much is velocity in direction x, multiply by this cross section in the x direction, means the area whose perpendicular is going to the x side. So this is the area, right? So this is perpendicular to the direction x. So this is ax. So how would I calculate that? If I know the AB, multiply by the width of this complete flow, that would be my cross section. Yes or no?
Yes, sir.
Right? So for that, your width of the flow is the W, and y is that you are going vertically up. So if you multiply W by y, you will get a dA along the line AB. If you want to calculate dA along the line BC, so what are you changing here? You are changing x and your width. Width again same. So width again the W, you are changing by dx. So this is the dA along the line BC. Fine. And now the direction of that, because you choose the direction of plane, is always go upon outside the fluid only. So in this particular, the side AB, your direction of plane is going to minus I side. This side, what about this side at BC? Will it be minus J or plus J?
Plus J.
Huh? You are talking the fluid flow going upside. So your fluid is upside. So your plane coordinate is outside in minus J side. Okay?
Yes, sir.
Right? So you got the dA. Now, once you know the dA, so how would you calculate the flow rate? To calculate flow rate, you just calculate U into dA, right? V dot dA, you do that only, na, right? Just to calculate your volumetric flow rate.
Yes, sir.
Right? So if I will calculate the how much flow is going across this section AB, so if I multiply your U, the U is the flow in this side, your dA is W into dy, and let's see what will I get. So this is what your dA equal to this at point B, this is at point BC. So let's say do it one by one. Now, if you want to calculate the total derivative of psi, because psi contains x and y both terms, so if you want to calculate total derivative of psi, so you will calculate partial derivative with respect to y multiplied by dy plus partial derivative with respect to x multiplied by dx. So this would be your total derivative of the psi, because psi is the function of x and y, correct?
Correct, sir.
Right? Now we want to calculate the flow rate across the section AB. So the formulation of to calculate flow rate is V into dA. I know V vector. So V vector is what? Ui plus Bj, because now you have only two components, x and y, right? So this is the velocity vector Ui cap plus Vj cap. dA I already defined there, W into dy minus I cap. Correct?
Yes, sir.
Now, if you say the dot product, so dot product of I or J would be 0. So wherever you have the I, means I and I are same, only then you will get a dot product here. So your second term V dot J bj dot w dy into I cap would be the 0. So you will get only first term. First term would be minus w into u into dy. Correct?
Yes, sir.
Fine. Or you can think from the other way also, because if we are talking about the flow on this side, so v velocity component is the 0, because v velocity component cannot throw the fluid in this side. So only u component can throw the the flow in this side, right? That is also the the another way to understand it. So you got this w u into dy. Now you substitute your the expression of u. So expression of u is del psi upon del y, right?
Yes, sir.
Correct or not? Now
Yes, sir. Yes, sir.
this is now in terms of partial derivative, and here I wrote it total. Is it true or not? What would be the total derivative psi along the line AB? So if I calculate this d psi along the line AB, is my x changing along the line AB?
No, sir.
No, no. So this term is getting cancelled because your dx is not getting changed. Your dx is the 0 along the line AB. So this term is getting cancelled. So your total derivative along the line AB is coming thus del psi upon del y into dy. Therefore, this particular term has been changed by d psi. Okay.
Yes.
Now I want to integrate the total flow from point A to B. So I can integrate from A to B. So you got here psi B minus psi A, and then psi B is streamline 2 and psi A is the streamline 1. So I can get here psi 2 minus psi 1. Now from here I can get this. Okay, let me change one thing here. So because once I integrate here, it will become actually your QB here. Okay. So you will get this your QAB. Now you can calculate QAB upon your W is just say psi 2 minus psi 1, which is equal to, because most of the time you are interested only in the magnitude, how much flow is going, no matter whether it's going to plus side, minus side. So if you want to calculate the absolute value of that, you are just getting that Q flow rate across the section AB per unit width of the flow is just a psi 2 minus the psi 1. So the somehow if I know the stream function value, so just getting the difference of the two, I can calculate how much flow is going. So that is the ease of the calculations. I need not to integrate again so many things. Okay. It is fine.
Yes, sir.
Now same way can we do the can you people do for along the section BC? You people try for BC. This is the section BC. Can you do the same way as I did for this case? I did for section AB. Can you do for BC section? Just do the same way. Let's see what is coming. All of you should do it. This is what we did for the section AB. Now same thing you do for section BC. So area across the section BC is this is our W into dx minus j cap. D psi would remain same function. Only thing here at the place of AB you will just write BC. Here also you will write BC. Here you write BC, and then substitute your DABC here. That will the W into dx minus of j cap. Substitute your expression for what will you get here, and then see. Let's see what is coming.
सेम आ रहा है सर।
आ भी गया कि नहीं?
आया सर, फोटो भेज देता हूँ।
नहीं नहीं, फोटो मत भेजिए, आई ट्रस्ट। What about others? Any other student got the same thing?
Yes, sir.
Yes,
So,
sir.
okay. So I also did. So you have this. So just substitute the same thing here, and again you got the same thing here, right? So this is the flow rate across the section BC is going this side. Per unit width of the flow, that is the entire width of the flow, is again came psi 2 minus the psi 1. So somehow if I know psi, I can easily calculate what is the flow rate going between 2 points. And this actually being helped to calculate somewhere flow in open channels actually. So that calculation part we will do when we will do the practice problems actually. Now this is the problem actually. So this is the problem for you. A velocity field is given to you that u y upon h equal I cap. It means this flow is going in purely x direction because you don't have here j cap and all, neither j cap nor k cap. So this actually flow is going totally in x direction. And this is your totally your x direction component of the velocity. Practically your u is given by u y upon h. First thing, you have to find the extreme function for that. Second part is that you have to find a location that divides the flow rate into two equal parts. Means ये जो flow कर रहा है, so this total flow is of height h. Okay, because here you have y upon h. So y upon h means the time you will put y equal to 0 means you are here at the plate. Your velocity is 0. As you will move up and up, as you will reach a point h, you will get a highest velocity, which is u only. Fine. So this is flow over a flat plate. Now you have to find the first thing, the stream function, means psi. What would be the psi for this velocity field? Once you calculate the psi, you have to locate a point which divides this flow in equal part. Means as you will go up from the plate, your velocity is continuously increasing. So it doesn't. You cannot say that half of the height can be treated as the half of the flow. No, because top side velocity is high, bottom side velocity is low. So bottom section would be a thicker one as compared to the top section to have the equal flow rates. Getting the point or not? Just like you have a conical cylinder and you want to distribute the quantity in two equal parts. So the bottom one would have the highest part because they are the conical shape, and top section would the small one because they are the diameter is the larger. Same thing here also. So can you people drive the stream function for this? This may help you. This you can say that your d psi is given by this. First thing, your d psi is given by del psi upon del y dy. So this is total derivative. Other thing is the how we have the define our u and v. This is how we have the define, right? कहाँ define किया हमने? This one. In terms of psi, u is given by del psi upon del y. So you already have u there. Equate to this and find it out. And v is given that minus del psi upon del x. So just do that and let's find what will you get. Stream find, this entire term is your u. Capital U y upon h is your entire term of u. आ गया किसी का?
Yes, sir.
Okay.
Sir, psi की
So
value half u by a square over h.
yeah, so you can see my thing also. So you have here the u is given by this, that del psi upon del y equal to u. So don't get confused. This is a capital U, this is the small u actually. So now you have this one. Now you have psi, you can integrate it with respect to y, and a function of fx actually, which we don't know actually. It could be in any function, or the EGS case you can consider is 0 actually. So that you will integrate it here. So at y equal to 0, your psi must be equal to 0 because you have 0 flow there. So if you will get that from this condition, your the fx is coming equal to 0 to satisfy it. Okay. So you got your this function of also what value of this function is. So finally your psi came u y square upon 2h. Everyone got this one or not? सभी का आ गया?
Yes, sir.
Right. Now
Yes,
we
sir.
want to divide this into two equal parts. Okay, जो flow है आपका, the next part here is we want to locate the value of y in terms of h, which divides this flow rate into two equal parts. अभी हमने पीछे क्या किया था? How to calculate flow rate between 2 points is this. This is what the psi 2 minus the psi 1. So let's say you have taken three stream functions. One is at bottom, one is the somewhere in the middle, one is at the top one, right? We can do that way. We want to just divide only in three parts, right? So we just need three
Yes, sir.
stream functions, right?
Yes, sir.
Right, so we can do same thing for that actually. So here you have psi. So once you get psi 1, so psi 1 would be at y equal to 0. That would be your u, y0 would be the 0, and that would be your psi 1 equal to your 0 only. Let's say psi 2. Psi 2, I don't know what place is that. So that is in terms of y only. So let's say the psi 2 is just u y square upon 2h. That is your psi 2. Let's say psi 3. So psi 3 is just, you are just calculating at the top surface. So top surface y value is the how much?
H.
Y value is just h. So I will put here at y place, I will put h here. So you will get here uh by 2, right?
Yes, sir.
Correct or not? So I will calculate flow rate between the streamline 2 and 3 would be how much? Your psi 3 minus psi 2. That would be flow rate between that. Flow rate between psi 1 and the psi 2 would be psi 2 minus psi 1, correct?
Yes, sir.
Yes, sir.
So if you will do that way, so let's say here, stream function is the mean the maximum at y equal to h, means you are at the top surface. So that is y max would be the uh by 2. Now you already have the formula, this one, q per unit width of the flow, that q by w, which you have derived. So this is the maximum flow, right? U max minus the U minimum. So U minimum is at y equal to 0 only. So you will get this is UH by 2, right? That is your Q, total Q, right? Now you want the half of that. So half of that would be 1 by 2 of the U max here. So that is the UH by 4. And then equate it in terms of Y here. So finally your Y is coming H upon under root of 2. आ जाएगा सभी का? नहीं आता है तो करो अभी, just do it actually. Or do at the way I told you there, just calculate psi 1. Psi 1 is equal to 0. Psi 2 is u y square upon 2h. Psi 3 is uh by 2. Calculate the difference of psi 3 minus psi 2. Equate it to y, psi 2 minus psi 1. And then you will get your value of y. Is it coming?
Yes, sir.
Now, can anyone think that from where this expression will come? ये वाला expression. This is not a magical formula, right? It has come from somewhere. Can anyone think from where this has come? Have you solved any problem where you have derived the velocity expression?
Yes, sir.
Yes,
Momentum
you
balance.
did a momentum balance for the rectilinear coordinate also and that also. We were talking in the last class over a flat plate. So there you got a parabolic profile. So ideally it comes a parabolic. But sometimes people, for ease of the calculation, they say the linear profile also. Okay? So it comes only from the there. So let's say you are taking the linear variation of the velocity. So at y equal to 0, your velocity is the 0. At y equal to top plate, you have the highest velocity, which is u. And this is just a slope of the line. Slope of the line is u by h. And the equation of the line is what? Y equal to mx, right? Yes or no?
Yes, sir.
Yes,
So
sir.
y for you here is v. The slope is u by h, and your x is here y. So that way also you can drive it here. Now this is helpful us. We can calculate the maximum velocity. Can you calculate the maximum velocity of a river without doing any hi-fi with the measurement? Can you think for that? How might this calculation would be helpful? Tell me that. How can you calculate the maximum velocity or best velocity or maximum velocity would be on top of the river bed only? So is there any means that how can you calculate the maximum velocity of the river? Whatever you have at present in your hand or at your home. Anyone can think about it? Give some answer.
सर जहाँ साई मैक्सिमम होगा वहाँ वेलोसिटी मैक्सिमम होगा.
क्या करेंगे?
सर जहाँ साई मैक्सिमम होगा वहाँ वेलोसिटी मैक्सिमम
अरे
होगा.
साई को छोड़ दीजिए, फॉर टाइमिंग साई को छोड़िए अभी. मैं कह रहा हूँ आपके पास में एक द रिवर है, द रिवर इज फ्लोइंग इन फ्रंट ऑफ यू. What means, how can you calculate without having anything, whatever you have in your hand just now? Can you calculate the velocity of the river, actually the highest velocity of the river?
So velocity function हो तो उसको differentiate करके calculate कर सकते हैं. मतलब
अरे भाई
maximum
मैंने
minimum
क्या
का
कहा?
concept.
What I said, I just said you don't have anything. You have whatever you have just now. You have your pen, you have your calculator, you have your watch, you have your clothes and all this. You can have your friend also, one of them.
सर हम कोई लीव उसके ऊपर
Yes,
थ्रो
yes. You came to the right point. Yeah, that's what. In earlier time also, people used to do the same day. That how much fast the flood is going. Flood is flowing. So what do? They put one person at that end, another person at the somewhere far away, means after 50 meter or let's say 30 meters something, so that they can the reasonable time. Put a leaf there, turn on your watch and ask your friend also, just note the time that leaf crosses here. So that's the easiest way to calculate the velocity without having any sophisticated instrument. Now, once we have that, now we can use this one. We want to divert the flow. So divert flow, how much should be the height of my obstruction? Because जब आपके पास में रिवर या कैनाल जहाँ जा रहा है वहां पे कहीं फ्लो मीटर फिट नहीं होता है. इरिगेशन के केस में where you have the irrigation by canals, you won't find any flow meter anywhere. Do you? So this is the only techniques. You know that I know the maximum velocity. I can calculate easily by leaf and all this. After that, I know by this calculation from here that this is the thing. I can measure the total depth of the water. Easiest part, I can dip a rod or maybe a dry bamboo and all this. So I can calculate how much is the height of the water bed here. Now from this only I can say is just h upon root 2. So from that I can calculate height and I will create that much height of the obstruction just to divide the flow into half portion. So these are the techniques being followed just to divert your open channel flows more, means mainly for that actually. So these are the applications for that stream functions in that way. Okay.
Okay, sir.
So because you have 11:20 now, your class time is also. So we covered the stream functions are there. So in next class we will cover this motions of fluid flow. What are the various types? So we will cover this one in the next class actually. And anything you want to ask, you can ask.